precisely in the middle of the land will be concentric. A concentric hole has an even amount of land surrounding it. Because the registration of lands and holes is not always perfect, the amount of the annular ring will vary. Depending on the class of product being built, it may be acceptable if a small portion of the hole is not surrounded by land. For example, Class 2 products allow up to 1/4 of the hole to be outside the land area. If more than 1/4 of the hole is not surrounded by the land, this can weaken the electrical and mechanical connection and decrease long-term product reliability. Another misregistration problem can occur with holes located in areas where conductors join the lands. If you drew an imaginary square, placing one corner in the middle of the land and the other in the middle of the conductor, the shaded area would be the conductor-to-land junction. If holes within the conductor-to-land junction substantially reduce the conductor width, there can be a problem. A severely reduced conductor may not be of sufficient size to carry the required electrical current. The remaining conductor may heat up and eventually burn away. And sometimes, the misregistration can be so bad that the connection between the conductor and land is actually severed by the hole. That's why it's important to consult with your lead or supervisor if you have any questions about these types of misregistration before processing the board further. Almost every printed circuit board will have some type of markings for identification purposes. The part number, lot number, and revision level will usually be indicated, as well as the type, location, and polarity of each component. Markings can be applied in many different ways, including stick-on labels, barcodes, engravings, and ink printing. One of the critical issues is the legibility of the marking. If the reference designator or polarity of the component can't be read, then the board should be rejected. That's because the correct component type and orientation won't be able to be verified. Another problem can occur when marking ink is accidentally applied onto a land. The ink can block the bonding of the solder to the land, thereby reducing the size and strength of the solder connection. This situation is more of an issue with surface mount solder joints. That's because through-hole solder connections require much more solder. However, through-hole lands should never have marking ink extending into the plated through hole. You've just been shown how to recognize the most common defects on bare circuit boards. We've examined defects in the base material, solder mask problems, damage or contamination on gold fingers, damage to traces or lands, and marking defects. A problem can be detected early in the process, or it can be detected during electrical test on the finished assembly. By recognizing bare board defects early in the process, you can become an even more valuable asset to your company. Your keen observations will have saved the cost of both labor and materials. That's why it's so important to look for and discover these problems as early as possible during the production sequence.
I'm looking over my bare board order that I overlooked before. I'm seeing defects that won't go away. Guess I'll be calling my vendor today.
The circuit trap results in more scrap. They gotta do something more.
Oh, I'm looking bare-board order that I overlooked before. I'm looking over my bare-board order that I overlooked before. I'm seeing defects that won't go away. Guess I'll be calling my vendor today.
The circuitry's gap results in more scrap. They gotta do something more.
Oh, I'm looking over